Imagine a 10-foot-tall primate weighing over 600 pounds. 300,000 years ago, this creature, Gigantopithecus blacki, dominated the Pleistocene forests of Asia. Yet, despite nearly a century of relentless global searching, we have never found a single body. The mystery began in 1935, when paleontologist Ralph von Koenigswald was scouring traditional apothecaries in Hong Kong. He found massive flattened primate molars being sold as ground-up medicine under the name dragon's teeth. Today, the entire physical record of this giant consists of 4 lower jawbones and a few thousand isolated teeth. There is exactly 0 skeletal evidence from the neck down. Without a skeleton to ground the science, human imagination filled the void. This total absence of bones provided the perfect breeding ground for one of our most enduring modern myths. Anthropologist Grover Krantz looked at those giant jaws and proposed a radical idea. The great ape never actually died out, but instead migrated and survived to become the creature we call Bigfoot. Krantz hypothesized a population of apes moved out of South Asia, walking across the exposed Bering Strait land bridge into the Pacific Northwest. This route is physically possible. Thousands of years later, early humans followed that precise path. But maintaining a breeding population of 300-kilogram ground-dwelling primates requires an immense continuous supply of calories. Hiding an apex herbivore of that size over a massive geographic range would demand huge swaths of undisturbed vegetation, and it would inevitably leave a trail of bones, waste, and physical disruption that we would easily find today. The actual fate of the giant garbantor was recorded much closer to its original home. Recently, scientists analyzed a single, nearly 2-million-year-old molar discovered deep inside Chuifeng Cave in southern China. Researchers managed to extract the tooth's enamel proteome, a highly durable sequence of ancient proteins preserved within the tooth structure. These specific proteins survived 5 times longer than any mammalian genetic material ever recorded. This cladogram maps out the evolutionary relationships using those extracted proteins. It places Gigantopithecus on a branch right next to the Pongo genus, revealing it as a direct sister clade to modern orangutans. This genetic link effectively closes the door on the North American Bigfoot theory. By examining the chemical isotopes locked inside that same enamel, researchers determined exactly what the animal ate. It was a highly specialized forest dweller, surviving almost exclusively on a diet of fibrous bamboo and sugary fruits found in Found's closed canopy jungles. Its massive bulk and hyper-focused diet made it the undisputed ruler of a very specific, stable environment. But that extreme specialization left the species entirely unequipped to handle rapid ecological change. Around 300,000 years ago, the climate across South Asia violently shifted. The dense jungles withered, replaced by dry, open savanna grasses. This graphic of a tooth cross-section shows the immediate impact on the apes. The thick, dark lines you see here are biogenic bands. They form irregularly when an animal experiences prolonged malnutrition and severe physiological stress. As simultaneously, early humans like Homo erectus began to expand into these open mosaic habitats, successfully exploiting the very conditions that were starving the giant. The massive scale that once made Gigantopithecus the master of the jungle became a biological anchor, preventing it from adapting to a world that now demanded flexibility. Simulation starved, the individuals that died fell to the jungle floor. The highly acidic subtropical soils of southern China quickly break down and dissolve large organic material like bone. Whatever fragments survived the soil were targeted by local scavengers. Prehistoric porcupines hauled the massive bones into their underground dens, chewing them to dust for the calcium needed to grow their quills. The giant ape never marched across a frozen land bridge. It slowly starved on isolated islands of shrinking forest, while local rodents ground its physical legacy into the dirt. The search for the lost skeleton continues today. Paleontologists run intensive excavations deep inside the sediment layers of underground caves in the Changzhou region. These treacherous tower-karst formations act like natural vaults, shielding deeper caves from acidic surface soil. If any post-cranial bones survived the porcupines, they will be buried here. The scientific consensus is clear and grounded in chemical evidence. The largest primate to ever walk the Earth fell victim to a changing planet roughly 300,000 years ago. Yet, looking out into the dense, misty, uncharted patches of forest that remain today, it's easy to see why we resist that finality. Because as long as the giant's physical form remains buried in the dark, our desire to believe in the unknown will keep its ghost shifting through the trees.